Okay guys, so I'm gonna try to show you the proof of completing the square. Supposing you have ax squared plus bx plus c equals 0. This can be rewritten as a into x squared plus b upon a x plus c upon a equals 0. Now, if we add half the coefficient of x here and we square it, so what I'm saying is that if we go x squared plus b upon a x plus half of b upon a square plus c upon a minus half of b upon a square equals 0. Right? Now, this reduces to a into x plus b upon 2a all square plus c upon a minus b upon 2a all square equals 0. So far, so we'll go to the next step. What we can do with this. Now from here, we go to this. We can say this is the same as a into x plus b upon 2a all square, right, plus a into c upon a minus b upon 2a, right, all square equals 0. So what if we take across this on the other side? Now we will have a into x plus b upon 2a all square, right, is equals to minus a into c upon a minus b upon 2a all square, right? We don't need to put a 0 anymore because we already take across. Okay? Now we'll find that the a goes out, and this minus 1 we have to multiply everything by here. So the next step would be like x plus b upon 2a all square is equals to, that will be positive b upon 2a all square minus c upon a. Okay, because this negative by this here gonna make this negative, and this negative by negative gonna give us positive, right? Let's go to the next step. Now from here we have x plus b upon 2a all square is equals to, this here is the same as b square upon 4a square minus c upon a. Right? Now, let's get rid of this square here by square rooting both sides. So this becomes x plus b upon 2a, right? If you want me to put that square root sign here, is equals to the root of b squared upon 4a squared minus c upon a, right? So now this is the same as saying x plus b upon 2a is equals to the root of b squared upon 4a squared minus c upon a. Good? Now we will try just a little more. So this will give us x plus b upon 2a is equal to, let's work out this here, 4a squared, let us say, I should just put it back here, right? b squared upon 4a squared minus c upon a root. Now we'll try to work this out. This is the same as 4a squared into b squared minus 4ac. A into 4a squared is 4a. 4a times c is 4ac. Root is equals to x plus b upon 2a. Okay? But the root of 4a squared, if you have 4a squared to the half, this is the same as 2 square a squared to the half. This gives us 2a. Sorry, let me put it here. So the denominator here gonna be 2a. So we're saying here that x plus b upon 2a is equals to the root of b squared minus 4ac all upon 2a, because the root here means if you have the root of a upon b, is the root of a divided by the root of b. All right? We'll go to the next step. So from here, we can have x, we take across this here. So if you want to write it plus b upon 2a minus b upon 2a is equals to minus b upon 2a plus the root of b squared minus 4ac all upon 2a. Right? Good. So what we're getting here now is this gonna cancel out. So we have x is equals to minus b upon 2a plus the root of b squared minus 4ac upon 2a. The denominator is the same here. Now the root is gonna be plus or minus here. So this is equals to x is minus b plus or minus the root of b squared minus 4ac all upon 2a. And that is solving by formula method you would get this. All right, so this is just a proof. I can go into some more explanation. Why did we use half the coefficient of x in this question? I mean, not a question, but in terms of showing this proof here. So I'm gonna stop here for now. Good.